Quantum computing just broke reality. The day science fiction became science fact. Google announced something that seemed impossible recently. A machine that doesn't just calculate, it rewrites the rules of the universe. And the craziest part? This breakthrough might break every limit we thought physics had. Let me show you how the world just crossed into the quantum era, and why nothing will ever be the same again. At the center of this shockwave is a device called the Willow Chip, Google's most advanced quantum processor. It doesn't just solve problems fast. It solves problems that would take regular supercomputers longer than the age of the universe to finish. But it's not just about speed. Using Willow, scientists did something wild. They shattered a 200-year-old law of physics, the Carnot limit, a law that defined how efficient energy systems could be. Turns out, in the quantum world, those limits don't apply. Here's what they discovered. At the quantum level, things like heat, entanglement, and correlation stuff that shouldn't do work can suddenly power machines. That's like turning invisible connections into fuel, engines, nanotech, materials, stuff that defies everything we thought was scientifically possible. The Willow chip doesn't just calculate, it sees differently. Using something called quantum echoes, it disturbs a single quantum bit and watches how that ripple spreads. It's like watching a butterfly flap its wings and tracking the storm it causes, but at the molecular level. This lets scientists map atoms and molecules more precisely than ever before, unlocking new paths in drug discovery, material science, and biology. It's a molecular microscope powered by quantum chaos. Willow's accuracy is unreal. It performs millions of calculations per second with fewer than one error every 10,000 operations. That's like threading a needle during an earthquake, while blindfolded and never missing. For perspective, the chip does more quantum measurements than every other quantum computer combined, in weeks. Other labs around the world are replicating the results. From Europe to Asia, research centers are confirming it. Quantum systems aren't just real, they're powerful. We're seeing new chips built specifically for biology, chemistry, and physics. The age of specialized quantum machines has arrived. And the biggest leap? We're closer than ever to fault-tolerant quantum computer machines that fix their own errors while running endlessly. The timeline for that? Not decades. Maybe 18 to 36 months. This tech is already rippling through industries. Pharmaceuticals, energy, finance. Any field that relies on simulation or modeling is about to explode. Imagine designing a life-saving drug in weeks instead of years, or predicting climate change with near-perfect accuracy, or simulating entire economies before they crash. That's not the future. That's the next 5 years. But power always comes with risk. Quantum computers can break today's encryption, meaning your bank, your data, and your identity could be vulnerable overnight. That's why countries are racing to build quantum-proof security, while others rush to be the first to break it. The stakes? Total control over digital infrastructure, economic systems, and even national security. And then there's the final piece of the puzzle, quantum AI. We're already seeing AI used to design better quantum chips, while those chips accelerate AI learning in return. It's a feedback loop, two of the most powerful technologies supercharging each other. Eventually, these machines won't just process data. They'll think in quantum logic. They'll reason and learn in ways we can't even predict. This is no longer a theoretical shift. It's a full-blown revolution. By 2028, quantum services could be mainstream. By 2030, hybrid quantum classical systems could be as common as cloud computing. Companies, governments, creators, anyone who adapts early will lead the next industrial age. The rest? They'll be left trying to catch up to a world that's already changed. Quantum tech isn't just another tool. It's a mirror that shows us how little we really know about the universe. It bends rules we thought were unbreakable. It unlocks possibilities we thought were fiction. And it forces us to rethink the very nature of cause, effect, and what's possible. This isn't just the future, it's the edge of something entirely new. So the question isn't whether quantum computing will change the world. It's, will you be ready when it does?